Today we are looking at another welder. This particular one is made by the guys over at Simder. I'm not too familiar with their company, but it does look like they have a lot of cool looking machines up on their website. This particular machine is called the SD5010 Pro, and allegedly it is a 5-in-1 welder and hot stapler. Now I'm a little bit of a cynic, so typically when a welder says that they are 10-in-1, 5-in-1, 3-in-1, I expect the welder to come with the stuff to perform MIG and stick, and everything else is like an option that you have to buy separate. You have to figure out what goes where, who you could buy it from, because sometimes the manufacturers of the welders don't actually manufacture the rest of the parts. So in this particular case, the hot stapler, the soldering iron, the TIG, the stick, and the MIG gun were all included in the kit, which off the bat is super cool of them to include everything that you need to actually perform the functions that they're advertising that their welder can do. The other cool thing is that the consumables, such as the hot staplers themselves, the solder, and even a couple tips for the TIG welder are all included with the kit as well. One thing that I noticed that wasn't included, however, was the tungsten itself for the TIG welder, which is understandable because for the price point that this welder is set up at, I'm just happy that it came with all the other stuff. The tungsten you can get pretty much anywhere else, which is cool. This welding package is actually a Kickstarter project brought on by the guys over at Simder, but according to their website, you can get pretty much all of this for less than $200. The only thing that I didn't find on their website that was or was not included was the TIG torch and some of the consumables, because the picture didn't show it. Obviously, it did come in my box, so I'm gonna have to find out exactly how this is supposed to work. But so basically, for a Kickstarter project, you're supposed to pitch in an X amount of money that's gonna go toward a specific product that you're gonna receive at a discounted price before it actually goes live. So let's say this welder, I believe it's set up to be sold for less than $200 before release, but then after the Kickstarter project ends, and the price will go up to $250, $300, whatever. Whether or not this is going to work the exact same way, I have no idea. The only thing that I know is that the guys over at Simder actually sent me this package. They asked me to make a video on it, going through it, criticizing it, tell me what they think about it before the actual product goes live. Maybe they're gonna make changes, maybe not. I have no idea. So in short, I'm not associated with the guys at Simder. They just sent me the product. I'm just going to review it, and then you guys are gonna check out my honest thoughts. So let's go ahead and get right into it. Like I mentioned before, there's a bunch of stuff here, and I want to clear a lot of this out, but let's go ahead and go through some of the smaller processes that are kind of like a bonus. Let's go ahead and look at the hot stapler and the soldering iron before we get into the actual welding part, because I've never actually owned a hot stapler, so I'm very curious to see how this works. So I'm going to be starting off testing the hot stapler because it seems like a very simple, easy thing to test. Lucky enough, the machine is actually a 110 machine. There's no option for 220, so a regular house plug will be more than enough to power this little welder slash multi-use machine. In order to get to the hot stapler controls, we're gonna have to push this circle button right here, and right now it is set to stick. That is TIG, that is Flux, hot stapler, and there we go. So we are at amperage right now, so it looks like we can go ahead and adjust the amps from 10 all the way up to 20, and let's see what that does. So at 10 amps, let's go ahead and test out this hot stapler. Three, 4, 5, 6, 7, 8, 9. It looks like about 10 seconds or so to get this thing to glow cherry red. So now let's go ahead and go back into these settings and then go up to 20 amps and see how fast it does it. I'm gonna go ahead and pull this one off, and I'm gonna put in a fresh one so that way you guys don't think I'm cheating. Alright, so I've got the old one right there. I just put a fresh one right here. Let's see how long it takes to get to about cherry red. And go. 1, 2, 3. Okay, so about 3 seconds. And it looks like if I keep holding the button, it might explode on me, so I'm going to let off. So way faster on the 20 amp setting. Let me see if I can find a piece of plastic so we can test this under real world conditions. Okay, so I think that was a little too hot. Let's go ahead and try this again, but under the 10 amp setting. Alright, so let's check this out. I might have not held it enough, so apparently it does work on these covers. I don't know what kind of plastic they are, but you know, it still works. Obviously on the one that I burned through, it burned through, but on the one that I went a little bit easier, it only went about halfway through. And let's see how easy it is to actually break these apart. Like I said, I might have not let them have enough time, but you know, it's actually pretty good. I can't break them loose. What'll end up happening is the stapler itself will end up breaking before I actually get these out of the plastic, which is really interesting. I used to see ads for stuff like this all the time online, but now that I've had it in real life, I could see where it could be pretty helpful around the house. Now that I've done this, I want to try something else. So I'm actually going to break one of these in half and see if I can put it back together. Okay, so it actually took a little bit of effort to break these two apart. It was not as easy as I thought it was going to be. After I took them apart, I went ahead and I snapped this in half. And now what I want to do is I want to take the hot staplers and I want to run one here and we'll run one there, probably as close as I can, to see how it reacts. There was an air gap in between the two covers on here, so now that there's not going to be any air gap, I want to see if it actually gets more stiff or if it's still just as floppy as it was before. So I've got a couple more staplers here. Let's go ahead and shove them into the holder and let's try this thing again. Alright, so I've got one here. Let's go ahead and apply this to here and go. Oh no, it moved. Okay, that was a fail. Alright, let's go ahead and try this again, but on the other side. Alright. This one came out a lot better, probably because it didn't move. Not like this one. The back side, it looks like I could have gone in a little bit deeper, but on the back side you can't even see it. So I'm sure if you were doing like maybe a body repair on some urethane or something, it would actually work pretty good. It doesn't look like it's flopping around. And although it does have a little bit of movement, it's probably because I didn't use enough staples. But if you were taking your time and actually doing this correctly and not doing this with one hand like I am, it would probably be a really neat tool. So I will give the hot stapler a passing grade. Let's go ahead and jump over to the soldering iron. Alright, so for the soldering iron portion, I decided to bust out my helping hands. I never really have to use these because I'm never in a situation where I can't just hold the wires myself, but in this particular case, I decided to put the camera on the tripod, and then we're going to be using the helping hands to hold these wires together. So if you guys have never soldered, it's actually pretty straightforward. You go ahead and strip off the wire, maybe about 3/4 of an inch or so, or 19 millimeters for those not in the United States. And so you go ahead and strip out some of this insulation, and this one's giving me a little bit of a hard time, but you strip off the insulation, you go ahead and you twirl them in an X pattern. And some people have different ways to do it. I like to do it in the X pattern. It does come out a little bit thicker. Some people just shove them into each other, but the ways that I like to do it is I actually like to just twirl them around kind of like this, like a DNA looking thing. And then I'm going to be using my helping hands. One's going to be helping me here, and the other one's going to be attaching me there. So I'm going to be setting the machine up to soldering iron. So the minimum temperature for this soldering iron looks to be, let's see, well, it could actually go pretty low. It might even be able to go, okay, 100 degrees is the lowest you can go for on the soldering iron. So let's see what the maximum temperature is. And I don't actually know if the soldering iron is on right now. It's on the soldering iron setting, but it might be getting there. So let's see how hot I can get this thing. I'm at 900, so 938 degrees is the maximum temperature. And the knob on the left doesn't really do anything, except that there's a little sign here that says soldering iron on off, push the button. So I'm gonna push the button, see what happens. And now there's a little lightning bolt here. So lightning bolt, I'm assuming it means that this thing is turned on. So let me see if I can feel anything. I don't know how long it'll take. Typically soldering irons aren't necessarily the fastest thing in the world. But I'm sure it'll get there, so I'm just gonna go ahead and hover. Oh look, it's already starting to, It actually got there fairly quickly, which is surprising. I have a lot of regular soldering irons and they don't heat up as fast as this. So I'm going to go ahead and tin up the tip of the soldering iron. Let's go ahead and build up a nice little ball. And I'm actually using the soldering iron that came with the kit, so I don't even know if this is rosin core or not. It doesn't say. Oh, it actually says Flux 2%. So let's see how well this thing operates. And if this doesn't work, I do have a backup set of solder that I can use just in case this one's not good enough or whatever for this wire. But let's see. So far, so good, actually. Let's see. Oh yeah, this thing's great. The soldering iron isn't even at maximum temperature yet, and I can already start going through this wire. This wire is not thin wire either. This wire is actually 12 gauge wire, so by no means is it like super thin wire. It is regular automotive grade wire, pretty thick stuff, and it looks like it did a really good job. All right, so let's go ahead. I'm gonna turn off the soldering iron right here, push the button. Lightning bolt went away, so it looks like this thing got turned off. Let's go ahead and get these things off of the helping hands. Ow, it's hot. And it is hot. So it's not the most beautiful soldering job in the world that I've ever done, but that could be from a number of different things, probably the solder itself. But I cannot separate the wires. So far the soldering iron seems like it's doing its job and it's doing what it needs to do. I've never had a soldering iron that was regulated by temperature, so that might be something I want to play with in the future. Maybe for thinner wire I want to use a lower temp, etc., because that does seem to be an issue. Mixed in with the consumables of the welder, it came with a bunch of stuff for the soldering iron, so it looks like if you wanted to, you can use this to carve plastic, maybe burn some wood, and maybe do a bunch of other stuff. And judging by how fast the soldering iron actually warmed up, I'm pretty sure you should be able to cook into some wood fairly easily. That's hot. To replace this consumable, you really just unscrew this part. You go ahead and pull this out. Yep, just pull it out like that. And let's grab a thick one. Let's do this guy right here. And then shove this guy back in there. I'm using a set of pliers because this stuff is super hot. In that short time that I was using the soldering iron, it's actually super hot, and I'm trying not to burn myself because it is a little toasty. Alright, so everything's back together again. I'm going to set these consumables on its side, and let's go ahead and turn on soldering iron. So lightning bolt is back on, and let me see how fast it takes for this little silver guy to change colors. We are about 15 seconds in and it looks like it's starting to change colors. Let me go ahead and try to tin it. I know I'm not soldering with this. Oh, yep, that's good to go. So let me see what it actually does to wood. What I just noticed about the soldering iron is that it actually has a soft grip right here. So if you wanted to write something or if you wanted to draw with it, you actually could. It's not uncomfortable at all. So it looks like I can go in and I can just start burning the wood. It does look like it does take a little bit more effort, a little bit more time to actually burn the wood. But if this is your thing, you can rest assured that it can definitely draw, write, whatever. I also picked a really thick soldering iron tip because I wanted to see how far and how fast we can push this soldering iron. But I do think that if you had this soldering iron specifically in a corner somewhere for these kinds of things, then I'd say that it's pretty cool. For the price that an actual just professional grade soldering iron would cost, the cost of this welder is actually not bad at all. So this is actually really nice. So in my opinion, I give the soldering iron a passing grade as well. So let's go ahead and move on to the next item. Next up, we're going to be going through the stick welding portion of this welder. In the last welder review that I did, some of you guys were pretty pissed off that I didn't go through the stick welding stuff. I'm not a big stick welding guy. I know how to stick weld. I know my way around it, and I know that flux core, or better yet, MIG welding, is just a better, cleaner way to weld thinner gauge metal. And 99% of the stuff that I weld is thinner gauge metal, so I never really have a use for a stick welder, but just for you guys, I'm going to go ahead and go through and review the stick welding function. So let's go ahead and plug in the 2 DIN connectors. Red is going to go into the positive on this welder. And I do like that they use DIN connectors. I think that's where most welder companies are starting to move to. They're starting to move over to DIN connectors, which is much better than the old wing nut and stud type. So we are all good here. Just give it a tug to make sure everything's good. And this welder did not come with any stick welding consumables, which is okay. They're pretty cheap, and I have a bunch here at the shop. So let me go ahead and grab a few and a couple pieces of sheet metal, and let's see how well this stick welder actually performs. That was absolutely terrible, but let's see how it ended up looking like. Hideous. I went ahead and grabbed a fresh rod because you guys know how difficult restarting 7018 is. So let's see if I have good luck or if I'm going to be made a fool by this rod. So it wasn't too bad. Took a couple of attempts to get it started. Let's see what the actual weld looks like. Okay, so this is 7018 on 80 amps. We've got the slag right here on top. Let's go ahead and break it off and see what it looks like. I mentioned before that I am not the best stick welder in the world, and especially not with 7018. 7018 is kind of a difficult rod to use. This is kind of what it ended up with right now. I'm sure if I clean off some of the slag, it'll look a little bit better. On my previous attempt, I think I did fare a little bit better, but I mean, not the best. I'm running into a few issues, and not necessarily related to the machine, more so relating to the fact that I'm actually running off of a generator. My generator is an inverter style. It's hanging out outside. I've made a video about that specific generator in the past, and for most things that I do, it works really well. But one thing that it does struggle on, well, actually 2 things, is plasma cutting and stick welding, because it pulls so many amps at one time. You could definitely tell that it was having a hard time burning through that 1/8 inch 7018. So what we're going to do is we're going to swap over to our 3/16 rod. This one will be a 6011, so it'll be a little bit easier to start, a little bit easier to maintain. With 6011, you have to work a little bit harder to try to make it look nicer, but it does end up doing the job for like 99% of things. So let's go ahead and switch over to the 6011 and see if I can do a little bit better job than I did with the 7018. Safety first, ground strap ready to go. Let's go ahead and load up my stick. And let's get started. So the real issue is that while the generator is on standby, it's running on a lower amperage than the amount that I'm going to need to actually get the weld started. So what's going to happen is that the weld is going to crackle, pop, and the generator is going to pick up RPM as soon as it sees that load. And once that load is consistent and the amps go up, then I'm actually able to drag the weld across and hopefully get it from point A to point B. So I'm going to go ahead and struggle with this first part, and then let's see if I can drag this across. Alright, let's go ahead and break off the slag and see what this thing looks like. Overall, I'd say it's not horrid. Obviously, there is plenty of penetration, and a weld like this would hold. The generator actually starts breaking up toward the end, and then I'm not able to continue the weld properly, and until toward the very end, I think you guys noticed that it kind of went kind of crazy. So I wasn't able to get a consistent weld all the way through, but I'm positive that if I could get this setup hooked up to ground electrical, it'd probably run a lot smoother, a lot nicer. Like I said, I'm not a big stick welder guy. There's plenty of penetration, so the welds would definitely hold. I'd say in this particular case, it's not the machine that's holding the welds back, it's actually the operator. So I'll go ahead and give the Simder welder a pass on the stick welding. Jumping over to the MIG portion part of the video, and I use MIG very lightly. That's what the advertisements call it, but it's really not MIG. There are no gas ports anywhere on the welder or on the colloquial MIG gun. But if you look at the display here, it actually says Flux. So it gives you an idea that it only welds flux core. It doesn't actually weld with MIG. That being said, I did go ahead and find kind of a good setting for flux core. I ran 030 or 0.8 millimeter wire. And if you look on the machine here, it is set up for flux with 0.8 millimeter wire. So everything is supposed to line up perfectly. Let me go ahead and show you what my weld ended up look like. And this was pretty much a first attempt. And it really doesn't look terrible. There is a lot of spatter. The machine does tend to run a little bit hot, and that's taken into account that I ran the machine at its lowest voltage setting, which was -3. I don't know what the base setting is. I'm assuming it's around 16, 18. -3 would put it somewhere in the 13 to 15 volt range, which for 16 gauge sheet metal is not bad at all. The issue is that when you turn up the amps so you can start penetrating onto the steel, the wire speed is either one of two things. The wire speed is too slow and it doesn't fill in the gap fast enough, or the machine just runs too hot. And if you're not careful, you can easily burn through, as you guys can see right there. And you can also tell that the machine is running a little hot because of the very fine spatter around the weld area. Now, does it penetrate? Yes, it does. There's actually plenty of penetration here and on the opposite side right there. So the machine actually does do what it needs to do, and it does it very well. The issue is that it doesn't fill fast enough. And I think my solution to that is to try different wires, maybe different wire thicknesses, to see if I can find a happy medium of what works best for this welder. It does level out pretty evenly. It didn't give me any kind of fuss, not even with my generator. Power management was very smooth. It hardly even hissed at all. Either way, for sheet metal, the machine actually does really, really well. I wish I had a 2-pound spool of 035 wire to test this welder on, but if you only have 030 and you're careful, it will do a really, really good job. It might just require a little bit of cleanup here and there, but for the most part, I'm actually pretty impressed. It actually looks pretty darn good despite the spatter. One thing that you do need to keep in mind when you're welding with flux core, especially on a machine like this that doesn't explicitly tell you, and I'm sure it does tell you in the manual, but if you're not bothering to read the manual like I am, just remember that when you weld with flux core, the MIG gun is the negative side and the ground side is the positive side. What you need to remember is that although this connection is black, and when you're doing stick welding, when you're doing MIG, this would go on the black port, on the negative port, but because we are welding with flux core, the ground side has to go on the positive, and the MIG gun will automatically be the negative. Like I mentioned, the machine is only set up to do flux core, so the gun is always on negative. But if it was a machine that could do MIG, then it would give you the option to run the gun on negative or positive. And so in those cases, you could accidentally have the polarity flipped around. But in my particular case, I just went ahead and by instinct moved it from negative to positive, and I had some decent results. As for the judgment on the flux core process, I will have to give this machine a pass. Power flow does come in really, really smooth. It's actually pretty easy to dial things in. I like the fact that there's 2 dials and not just one big dial. You can adjust speed and you can adjust voltage adjustment separately, which is what I always tell people to look for in a machine. So this is awesome. I love this right here. I do like the fact that it runs natively 030 because that's normally what body panels and things like that you're going to want to run 030 if you're running flux core, and if you're running MIG you're going to want to run like 023, 025 or thinner. You can get some thinner wires out there. So for flux core it does great. For MIG it's not applicable because you can't run MIG gas on this machine, so we're not going to give it a MIG rating because it's not capable of doing MIG, but it can do flux core, and some people call flux core MIG, but it's not MIG, it's flux core. So let's go ahead and move on to the final process, and that's going to be the TIG welding process of this machine. So let me go ahead and undo all of this stuff and then start fresh with the TIG. I mentioned earlier that included with this machine was all of the consumables except for the tungsten. So I've actually got two sizes here of tungsten. This one's 1/8, this one's 3/32. I'm not a very good TIG welder, so I like to use a thicker tungsten because it can take a little bit more abuse, but it's not as accurate as a thinner one. But unfortunately, consumables for the 1/8" tungsten did not come included in this kit. It only went up to 3/32. These were like $15 for a pack of 3, or for a pack of 10 it was like $40. So they're not necessarily expensive, but they're also not that cheap. So it is a good idea that you take care of them. We're also going to be using the included number 6 nozzle. I was going to use a number 7, but I can't find it. I must have misplaced it. And we're going to be using the appropriate 3/32 collet and gas lens. So let me go ahead and put this torch together, and let's see if we can get some good welds out of this thing. Alright, so this is the result. This was the first side that I did, second side, and then the back side that I did while I was trying to figure out the settings. So this side and this side, I ran them at 65 amps, and this back side, I ran it at 70 amps. Going in, this is what the first weld looks like, and I cleaned it up as best as I could, but it still got a lot of debris, especially in there, a lot of contamination in the weld. It also took me a little bit of time to figure out my mojo to try to get a good rhythm as we go across. Then we jumped over to this side, and it got a little bit better, but I felt like the amps were just a little bit too low, and I was putting in too much heat. So something about TIG welding that you'll learn is that when you run too low of an amps, your travel speed goes way down. As your travel speed goes down, you put more heat into the metal, and it's just a balancing act. You really want to pay more attention to your puddle than you do anything else, and that'll tell you the right heat range to run your machine at any given material. And then on this third side was the last one that I went through, and this one I think was the best one out of all of them. It's pretty uniform. There was a little bit of contamination down here at the end, that something caught on fire or whatever, but as you can see, it doesn't look too bad. That's all well and good, but you guys need to know it doesn't matter what the welds look like. Do they penetrate, and do they do what they need to do? So if I flip it around and we look inside the tube, so it's going to be a little bit difficult to see just because of where the position is, but if you guys can see that gray bluish line, there's one along here, one along the side, and then the shadow's not going to let us see the bottom one. But it's basically one for each side that we were welding on, and the molten gray blue tells us that we were probably getting more than enough penetration on this 16 gauge piece of steel. If you look inside the tube, there is evidence of penetration, but it's not as obvious. So for the lift TIG process, I'm gonna have to give this machine a pass, and for all 5 processes actually, I'm giving this machine a pass. So I really enjoyed my time working on this machine. The only real issue that I had was getting the stick welder to work, but it does work. It's just my generator that can't keep up with the demand, but that's no fault of the machine. Every other process was working fine, and like I mentioned, I was able to run 70 amps across the 16 gauge steel, and although my generator was not necessarily struggling, it was getting a decent workout, but it never got to the point where it overloaded my machine. So I'm pretty happy about that. I'll leave links to all this in the description down below. Like I mentioned, this is part of a Kickstarter program. By now, the Kickstarter program probably already started. It's probably halfway through, and depending on when this video gets released, it's already been completed. So go ahead and check these guys out. Hopefully you guys have a similar experience to what I did. If you guys have any questions, go ahead and post them in the comments down below. I will see you guys all on the next one. Night Wrencher signing out.